Hi guys, welcome to our next day of notes. Since we're starting a new day of notes, this is not video 3 or anything like that. Make sure that you're taking out a new piece of paper and that you're writing the new title across the top. So today's title is 1-2 Properties of Real Numbers. Remember, you can pause the video at any point in time if you need to write things down. So today, in our first video, we're going to learn about classifying numbers. So whether you know it or not, every number has a category that it fits into. It has a name. It has a type of number that it is. And a lot of times in our directions in this school year, we're going to use those different categories and classifications. So we want to make sure that you understand what we're talking about when we say, hey, this problem is going to have rational numbers in it. Well, what's a rational number? So that's what we're going to learn in this video. On this first slide, it's very heavy on vocabulary. It's a lot of writing. So what I'm going to do is I'm going to talk through it. And then at the very, very end, if you want to write everything down, you should pause. But if you don't want to write everything down, I'm going to tell you the most important things that you should write down. So right now, we're going to go through the different categories of numbers, starting with natural numbers. Natural numbers, which we can abbreviate using the letter N, are our counting numbers. So whenever we need to start counting things, these are the numbers that you're going to use. I have 1, 2 children. I have 1, 2, 3, 4, 5 apples, and so on. Notice that it does not include the number 0 because we don't really start counting at 0. We start counting at 1. The next group of numbers are called whole numbers. Whole numbers can be shortened to the letter W. The whole numbers are all of the counting numbers. And then we're just going to add one more number to the category, and that's the number 0. So if you start counting at 0 instead of counting at 1, we're now talking about whole numbers. Please notice that we've only done positives so far. Our next category are called integers. Integers is abbreviated with the letter Z. I'm going to be honest, I'm not sure why they chose the letter Z. I know that we're going to use I for something else later, but this is using the letter Z. Integers are all of the whole numbers and their opposites. Now in our next video, we're going to learn that the word opposite means opposite sign. So this is now going to include all of the negative versions of our natural numbers. Our next category is rational numbers. Rational numbers is abbreviated with the letter Q. Again, we're going to use the letter R for something else later. And so we're using Q for rational. Rational numbers include all numbers that can be written as a fraction. That means this includes every fraction in the whole entire world. It also includes all terminating decimals. A terminating decimal is a decimal that has a stopping point. It has a last number. For instance, 0.5 is a terminating decimal. The last number is 5. 0.137263975 is a terminating decimal because it has a last number. That can be written as a fraction. It also includes all repeating decimals. Repeating decimals are those ones where we draw the bar over the top. If you remember 0.2 with the line over the top, that means 0.2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, on and on and on and on forever. That's a repeating decimal. Those can also be written as fractions. So decimals that have a stopping point and decimals that are repeating, have a repeating pattern, those are rational numbers. Fractions are rational numbers. And since every integer can be written as a fraction, we just write it as a fraction over 1, all integers are rational numbers. All whole numbers are rational numbers. All natural numbers are rational numbers. In fact, almost every number is a rational number. The only type of number that's not a rational number is an irrational number. And literally, the definition of irrational numbers are numbers that are not rational, numbers that cannot be written as a fraction. We're going to abbreviate irrational numbers with the letter I. Irrational numbers are never-ending, never-repeating decimals. The most famous one is the number pi. Pi is a never-ending, never-repeating decimal. It does not have a pattern, so that would be an irrational number. Other common irrational numbers are square roots of numbers that don't have a square root. For instance, off the top of my head, I don't know the square root of 70. It's some really, really long decimal. So that would be an irrational number. Now, all of these different types of numbers put together, natural, whole, integers, rational, irrational, all of them together, they all make up real numbers. Real numbers can be abbreviated with the letter R. At this point in time in your life, you probably only know real numbers. And you're probably like, why are we even talking about real numbers? Every number is real. When we hit chapter 4, we're going to learn about imaginary numbers. And so we will, in this class, need to specify that these are real numbers and not imaginary. Okay, so that's our vocabulary. Right now, if you want to pause the video, and I might close out my video because the next screen takes up the whole PowerPoint. So I'm going to close this out. And, if you need to pause and you need to write, go ahead and write down. Otherwise, I'm going to move on to the next slide. So one thing that we're going to ask you to do in this class is we're going to ask you to list out all the different categories that a number fits in. So we need to understand how these categories work together. So we're going to draw a Venn diagram. Now, the Venn diagram is going to be really important for you to draw. And the other thing that you're going to need to know is you're going to need to know the abbreviations because it's just nicer to write things shorter. So if you need to go back and write down the abbreviations, you can. And then you definitely want to copy down everything from this slide. The really cool thing about classifying numbers is that it makes a nice nesting Venn diagram. Our smallest set of numbers are the natural numbers. 1, 2, 3, 4, 5, 6, 7, on and on and on and on forever. It goes on infinitely, but it is our smallest set of numbers. Now, our whole numbers contain all of the natural numbers plus also the number 0. So every natural number is also considered to be a whole number. Our integers contain all of the whole numbers and all of the naturals. Every natural is also a whole number and an integer. Now, it adds in some new numbers, the negatives, right? The negatives are integers, but they're not whole and they're not natural. And then even bigger than integers is our rational numbers. Rational numbers contain all of the integers, contain all of the whole numbers, and contain all of the natural numbers. And then it adds some new numbers. It adds fractions, it adds terminating decimals, and it adds repeating decimals. All right. Now, irrational numbers, those are completely separate because irrational is the opposite of rational. And so, we can't contain those within anything else. So irrational just kind of gets thrown over to the side. If a number is irrational, that's the only thing it is. It's irrational. It can't be anything else. And then all of these numbers and all of the numbers that you know up until this point in time in your life are all considered real numbers. If you need those abbreviations again, I'll write them in there. So for natural, hold on, I got to change my pen color. For natural, the abbreviation was N. For whole, the abbreviation was W. For integers, it was Z. And for rational, it was, and then for irrational, it was the letter I. Okay, so those are the abbreviations.